crazy how much an hour time difference like changes everything.
Ooh. Sorry, you're really quiet. I'm not sure.
Oh, so can you hear me better? Can you hear me better now?
It was me. I fixed it. Unless you fixed something too. I don't know.
I don't know. Okay. Just moving stuff around the mic just in case I had something covered it up. But yeah, it's crazy how much a 1 hour difference makes.
Where did you move to?
North Carolina, Raleigh. Yeah, I've never lived in the Eastern time zone before, so like it's weird, like all the shows and stuff and live.
You were in Central before.
Yeah, it's so late at night. But
I know. I grew up on the East Coast, and it was cool for me moving to Utah because I was like, oh, I don't have to be up so late. What like I remember like nights watching football games being up till like 11 o'clock at night, you know? I'm like, oh nice, like we're done by 9 o'clock. It's over. Like we're done.
Yeah.
It's
sure that.
Different. It was weird though to like start watching like primetime TV at 7 o'clock for me, like because I was like it's like a rush to like get to. We only have like one night a week. Okay, we watch The Bachelor on Monday nights. And yeah, my wife. It's my guilty pleasure, and my husband has now joined me. And so like on Monday nights, it's like always like a rush. We have to make a really quick dinner because I'm like, we have to hurry up so we can sit down and watch The Bachelor at 7. Anyway, okay. What do you think of this chapter?
What was that?
What did you think of this chapter?
Seems like pretty simple. Pretty similar to the past couple lessons as far as equations go. Nothing too complicated, but then again, it always hits me in the homework, like the group meeting quiz and the preparation. I'm like, this makes sense, and then homework, there's like 3 problems that I just don't understand. But
yeah, sure. How'd you do on the exam?
I did pretty good. Yeah, I mean, I've like kind of given up on hope of having like a 96 in this class like I planned. Kind of given up on that. So, but I'm still, working hard and making sure I get.
Yeah, that's how I feel like. I thought that I would do better on this than I did in the last one. But yeah, me too. The same.
Yeah.
Whatever. like right now, I'm just happy as long as I get a C. If I can keep good standing in my GPA, then I'm okay. So question 3. In a pie chart, why are the slices or sectors different sizes? So let's see here. The size of each slice.
That is C. Each slice represents a category, and the area of each slice represents the portion and total occupied by the category.
Did you go through this already?
Yeah, I went through the first couple of questions.
Okay, I'm like, wow, he read all his options so quickly.
Yeah, no, don't. Like, I didn't read it that quickly.
Awesome. Okay, then how are bar charts and do you know how to say that word?
I do not know. No, I don't know the correct pronunciation of that. No, Partu, I guess.
I keep saying Perito in my head, and I'm like, it sounds like I'm saying some like Spanish, like I'm saying like, I don't know,
right,
quesadilla or something.
Right. Okay. Yeah, this one I have C. The only difference between a bar chart and a Partu chart is the bars. Because remember, this one was the only difference was it goes in descending order.
Right.
That's what makes it. Yeah. So yeah, these first couple are just like cruising through, but then when you actually get into the calculations, that's where I was like, slow down.
All right. So we choose the following information. Conclude that P is normally distributed if NP is greater than 10 and N times 1 minus p is greater than or equal to 10. Oh, that's right. Okay. So is p true proportion or the sample proportion? And that is the sample proportion. Is that right?
So I may be wrong, but I understood it to be a true proportion, and the sample portion was the z-score from the online textbook.
Let's see here. So I thought there a capital P was the true proportion. Let me look back here.
That could be, yeah. Let me see. So you know about Control F search?
Yes. Do you
Yeah,
use that
so like,
here?
yeah, I use that in the textbook a lot of times for like definitions and stuff to better understand it, and I fill that out on my note card every week.
You just search like true proportion.
Yeah, exactly. So you can search true proportion, and then
Okay.
so let's see. The first thing that comes up is where P is the true proportion population, but
Sample
and
proportion.
then when you search sample portion, the first thing other than those all the introduction things was the z-score. So it says answer the following questions, number 7, to find the z-score corresponding to your sample population proportion.
Except that the sample proportion ends up being the area, not the z-score. Like it shows you how to compute the sample proportion using like by first finding the z-score and then using the normal probability outlet.
Oh, true.
So the z-score itself wouldn't be the sample proportion, but
right.
But
yeah, I don't know. Then I could see it being either.
What
yeah.
symbol actually signal? If the true proportion of people who found, so I'm looking under 3.3.2. True proportion of people who support a particular political candidate is okay. So yeah, you're probably right. The lowercase p is the true.
And if nothing else, it's 2 attempts, and we know it's the other one. We'll learn.
No, I think you're right.
So, yeah.
Okay.
Question 7, what is n? That's still the sample size, right?
Yeah.
Yeah. Okay, question 7. This is where I was slowed down drastically. If p equals 1/4, what is the smallest n that satisfies the requirement?
Okay. I think this sounds like review that I struggled with.
Yeah. So I just plugged in 1/4 on the right equation where n times 1 minus p is greater than or equal to 10. And so when you do 1 minus 1/4 to get 0.75, so you're trying to find out what times 0.75 basically equals 10. And that is what I've been doing recently. But I'm sure there's got to be a better way than plugging in. Like, is that where we use the big entire formula of
Wait, so which formula are you using? You're using just the p equals x divided. No.
No. The what it's talking about satisfying is right before question 5, where it gives the 2 NP is greater than or equal to 10, and then n minus or 1 minus p is greater than or equal to 10.
Question 5 on the textbook. Sorry.
No, sorry. Question 5 on the group meeting. Just above it, it gives you. Yeah,
okay.
yeah.
Sorry.
No problem.
Question 5. Oh. Okay.
Yeah, it says for the next 3, and that was the third. So that's the one it's talking about.
Oh.
So I'm sure there's some way to do it other than just, plugging in numbers, but
Let me look in the text and see.
Yeah.
What is this question? Looking for like, see if there's an example that is similar at all. Ugh. Oh, here's this thing. If NP is summary, there's a thing that looks like this. Greater than or equal to 10, you can conduct and thinking about whether to figure out if n. Yeah, no punching in the number sounds good to me.
So right now it looks like 13.25 works for the right equation, the right side, but can you try that on the left side?
Yeah, just a second, sorry. Okay. You says 13 point what?
13.25. Oh wait, okay, it has to be a little bit bigger than that. Let's see.
Okay.
13.3, let's see if that works. Times 9 point. Not quite.
Away today.
All right. I don't know if I'm understanding this right. So you're just wanting me to multiply. So I just need to do the NP. Like, so 13 point whatever times 0.25. And that is way too low. I mean, it is still.
So.
Yeah, it's low. It's lower than 10. Not greater than 10.
Oh, wait. So 13 times 0.25 is how much?
It's 3.31.
Oh, wow.
So not higher than 10.
Okay, so the right side, I guess, doesn't matter then, because I found out, I just spent a couple minutes finding out that 13.35 exactly times 0.75, which is the 1 minus 0.25, gives you like almost exactly 10. But I guess that doesn't matter because you're trying to find the lowest that n can be. So we have to find out the lowest, basically that whatever times 0.25 then gives you 10. Yeah. So wait, let me think about this in like on the paper here for a second. So 0.25 times n equals 10, basically. We're trying to find out what the lowest n can be to equal 10. So all we have to do is divide 10 by 0.25. Right? That should give us the lowest that would equal n. So 40?
40, let's see here.
So if you do 40 times 2.25, it gives you 10. That works on the left side. And then 1 minus 1 minus 0.25 is 0.75 times 40 is still greater than or equal to 10. So it's 40. Man, I don't know why I made that so complicated.
So you just divide.
So I set it up, because on the right one, it doesn't matter basically because you're trying to find the lowest it can be. But if it was like the highest, you'd probably, I guess the highest is infinity, whatever. But anyway, so what I did is just looking at the left side of the equation of the n times p is greater than or equal to 10. Well, we know p is 1/4. So basically, you have n times 0.25 equals 10, right? Because we're just not worried about the greater than. So then all you have to do is take that to the other side, the 0.25, divide it by 10, and then you get what n equals the lowest. It can be equal 10. So I don't know why I made that so complicated, but yeah.
Okay.
So then you get 40.
Okay. All right. Here's the following information to answer next question. Suppose n equals 24 and p equals 0.4 of p, or this. What is that little? Do you know what that triangle means?
I don't know how to pronounce it. No, I don't know what it's supposed to be called. I think point estimator. Because when you go down to the summary at the very bottom of the online chapter, it says the P with the little triangle up top of it is a point estimator for true proportion P.
Okay.
So I guess we can call it point estimator.
That? Round answer to 10th place. Okay, so one. Okay.
I don't understand how to find this. I don't understand what this is asking. Do you?
Okay, so let me look here. I think the mean is just 0.4 because I think that, so there was an example in the preparation, where it says the last question in the prep. In part A, it says of the sampling distribution, and then it says that the mean. It says the mean is the what they're putting as P in the information. It's the same thing.
Okay.
Do you have it up? The preparation assignment?
Yeah. I do.
So number 9, it says 7% is the true unknown percent of the population that do not have traditional phones and instead rely on cell phones. So it says in parentheses then 7% is P. And then in A, it asks you what is the mean, and if you look at the answer keys, is 0.07 or 7%. So I'm thinking that the answer to this is very easy. It's just 0.4.
Yeah, you're right. I think you're right. Yeah, 0.04, that's right.
It's 0.4, okay. Right?
Yeah, 0.4.
Okay.
Sorry. I was thinking 0.4, yeah. 0.4. The P.
Okay.
What is the standard deviation of the point estimator?
Okay. So for that, we have to take the formula, the square root.
Yeah, this one's complicated.
P times 1 minus P over N.
Over N, yeah.
And so we get the P is, okay, so how did I figure this out before? It was weird. I'm looking at all the numbers here. Okay, so if P is 0.4 times 1 minus 0.4 over the sample size. Or maybe it's the z-score I had a hard time with, but yeah, I think this is pretty easy, straightforward. The standard deviation, is that what we're figuring out? Okay. And the sample size was 24. Okay. Okay. One.
And to the 10th place, right? Let's see. See, this one makes sense. It's simple. So I got 0.6.
Okay, I'm almost there.
Okay.
Oh, I got 0.6 0.016. Hey, what the heck did I do wrong? Okay, so your formula reads 0. Oh, I didn't use the square root yet. Okay, hold on. Nope, I still did not get the same thing. Okay, so does your formula read 0. So the square root 4 times 1 minus 0.4 over 24 or divided by 24. Okay, so what did I calculate?
Wait, okay, I may have gotten it different though. So that is supposed to be everything is under the square root, right?
Yeah.
Yeah, that's what I got. Then you may have just put it. I can check, but so let's see. So I put in Excel, and I put equals square root parentheses 0.4 minus parentheses 1 minus 0.4 parentheses divided by 24 close parentheses.
All right, because so I didn't do it that way because I messed up when I did it that way before, like because within the prep assignment. So I'm trying to do it by hand so that I don't mess up because I've had like too many parentheses or something in my. So let me just look at this by hand and then I'll try it in Excel. But 1 minus 0.4 would be 0.6. 0.4 times 0.6 then is 0.4 times. Oh, Jesus. Here we go, equals 0.4 times 0.6. Okay, so that's where I calculated wrong, I think. All right. Okay, so 0.24, then we divide that by 24. Divided by 24, and then we take the square root of that. Oh. I still don't know if I'm gonna get this right. Dang it. Square root. Yes. I got 0.1. Why did I get 0.1? Okay, let me try it and just do the whole thing in one cell in Excel here. Equals square root of 0.4. Okay, so I still got 0.1 when I did it all in one formula. So I have equals square root 0.4 times parentheses 1 minus 0.4 parentheses, or close parentheses, I guess. So, okay, divided by 24 close parentheses.
Oh, wait, let's see. I just realized. So I have square root parentheses 0.4 minus parentheses instead of minus times. Is it so? Let's see. Let's see. I'm trying to think now. So what's 1 minus 0.4? That's 0.6, right. So maybe I should just do...
Well, it looks like you said you have the first, so you have square root parentheses 0.4 minus.
Yeah.
Because it should just be times. Because that 0.4, you want to multiply it by 1 minus 0.4.
Right. Let's see here. So, yeah, so I need to redo that. So it's square root 0.4 times... Wait, so what do I do with the negative sign?
Oh, okay. So, okay, so square root 0.4 times, and then another parentheses 1 minus 0.4, close parentheses. So like 1 minus 0.4 should be in parentheses.
It automatically multiplies it?
No. So...
And it's a minus that too. Or is it?
Yeah, so you need to subtract 1 minus 0.4. Formula, it's P and then times 1 minus P. Does that make sense?
Oh, it's times.
P is 0.4. So 0.4 times 1 minus 0.4 is the top half of the fraction.
Or is it just P minus 1 minus P parentheses? Like there's no multiplication?
No, in the text, 3.1. So in 3.1 in the text, the example, and then number 6 shows the standard deviation formula.
Yeah, I see. Okay. Why do I have P minus 1 minus P for some reason? Okay. Okay. And what did you get again?
0.1.
Okay, yeah, I got the same thing.
Okay.
Makes sense. I just had the equation. Okay, what is the standard deviation of the point estimator?
Oh, that's not my. Wait, did I miss a question? That's the one we.
Oh, sorry. Yeah, wrong question. 10. What is... Okay, so it's not point estimator. I just figured out. It's the population parameter. That's what it is.
Yeah, I think that was even a question.
Yeah, I figured out an online textbook a second ago. But okay, but I don't know how to calculate the population parameter now that I know what it's called.
Okay, so this is the one where I think we figure out the area, so we have to compute. This is where it's compute this easily. Hold on.
So how do we do this one?
I'm looking to see if I can be sure of this. Hold on. Curve when a coin is tossed. Okay. What's batting averages? Determine the probability she'll get. Okay, so What is okay? So that P is just the so just like the one we did before.
Uh-huh.
The mean P. Now I'm so confused. This is so confusing.
Yeah, like I get question 11. It's the same thing again. It's the standard deviation equation, but the population parameter P. I'm not sure. It can't be that complicated because I don't know.
Because it's the first question under this. Like you'd think, like usually they're
Right.
like they're trying to give you information to like complete it. I want to say it's 0.3, but I don't know for sure. But
Right.
let me just check this example. Sorry, and my daughter won't stop saying "let it go" in the living room, and it's like in my ears. I'm like trying to concentrate.
Oh, I found it. No worries. Okay. Population parameter equals x divided by n. But what is x?
Oh, yeah.
People are polled, and x equals the respondents of.
Yeah.
Example.
For that, like that's the observation. So
yeah. So x is 35 in this case. See the 35 that talks about. So it would be 35 divided by 100, which should just be 0.35 is our answer for 10.
okay.
I have that written down on my
35.
paper, my notes. 0.35, that makes sense. Because it says rounded 2 decimals places too. So that makes sense.
It doesn't make sense to me, but
It doesn't. So yeah, so the equation is x over n.
So I have
and so
that.
your x is the 35 hits in your
I'm
next
not
100.
sure that x is the 35. Like it's just weird to me because I'm looking at like my notes and I see like the example I used was when somebody knows that like that because that this was the number. So like I used the election like the poll result like example. Case like 565 people responded that the Republican they would vote for the Republican candidate. So it was like 565 out of all the people who responded, or the people who were polled in 24. So it's like a number that not the number that they're asking about. And so I'm just I'm like I don't know, like, but I'll take it for now and we'll see what happens.
Yeah. Yeah, I may be wrong, but that makes sense to me. So
okay.
I think it's
because I'm confused. So your understanding is good. Okay, so what is the standard deviation then? So we just do the same.
Yep.
And P being
0.3.
Okay.
So we have square root.
P is 0.3, but the population parameter P is
0.35, but I don't think we use that and find the
sense. Okay. No, I'm sorry. I was trying to explain that in my head.
Okay.
Okay. And the sample size is 100? Yes.
Yes. Yeah, so in Excel, I'm doing equals square root, parentheses 0.3, times parentheses 1 minus 0.3. Close parentheses, divide by 100 again.
Yeah. Okay.
And what are we rounding to? Three
Three
decimals.
decimal
Yeah.
0.046.
58.
What?
Oh wait. 3 decimals. 0.046.
Okay.
12. What is the z-score?
So we would take. Okay, so this one was the one that was weird to me in the prep that took me like a million tries to figure out how to do it.
Right.
I had to like convert the actual value to a percentage. The P percentage. Anyway, so Brittany's batting average. So the z-score is the value minus the mean over the standard deviation. So the value is 35, right?
The value. Let me think.
Oh. Minus the mean, which is okay. So 35. So it would be 0.35 is the value because it's a percentage we want because the mean is in a percent. It's just 0.3. That makes sense. 0.35 minus 0.3 over 1. Oh, the standard deviation over. What did we just figure that out to be? 0.046. 0.0.
So you got point in the equation 0.35 minus 0.3.
Yeah, minus 0.3 divided by the standard deviation. That's what I'm just clicking on.
What? How many? Yeah, how many decimal points do we use in the standard deviation? Because it's so long, you know. I guess we could just
they
go
always
back
say
to the
to, like,
Excel
wait,
sheet.
yeah, that's what I'm in my Excel sheet. I just click on it. Huh?
Yeah.
Okay. But I got some kind of crazy high number for a z-score. You know?
Yeah, I got 1.09.
Oh, that sounds right. So I did not get that. What did I do wrong?
Oh wait, that isn't crazy high. That would make sense. So yeah, I did is I just took, so 0.35 minus 0.3 is 0.05. So I just did 0.05, and then on the Excel sheet, the answer that we got, I just like kept clicking the decimal place right to show more decimals, and then I said 0.05 minus, and I clicked.
I know
Now you can
that.
click on Excel. So it gave me like a more accurate answer, basically.
Yeah, I just didn't put parentheses where I needed them in my calculation. There we go. So 1.09.
Yeah. Let's see. 3 decimal places. Yeah, 1.091. Sweet. Okay. That starts to make more sense. Let's see. 13. What is the probability Brittany gets at least 35 hits in her next 100 at bats?
Okay, so let's go to the normal probability applet and put
Okay.
score in.
What do we put in here?
So we put our z-score 1.091 in at the bottom.
Okay.
And then, so at least is what we need to figure out. So equal to or greater than, right?
Right. Yeah. So just
right.
just the right side, because the 1.091 is like you have to look at it like on the bottom, like okay, the 1.091 is like just slightly to the right of 1, so everything up to the right of that right red line. Does that make sense? If it was negative 1.01, then it would be the middle and right.
Okay. So 0.1376. That way you got.
Yeah, it wants us to round to 3, so it'd be 0.138. So yeah, 0.138.
With my watch on my wrist.
Yeah, and that just logically it seems so low because if her batting average is 30%, it shouldn't be that far off that she's going to get 35. I guess maybe.
But
I guess that.
Yeah, because it's like at least like
Yeah.
that, like she's guaranteed like the only 13% of the time she's
And that's still
guaranteed.
higher than her average. Yeah.
Yeah.
Okay. Cool. Okay.
Oh no, it's changing up on us.
Is it over, honey?
yeah.
Sorry, I have to put on a new movie. Come over here. Okay. Sorry. Okay, so question 14. So we use that information above. So the standard deviation, we should be able to work that out pretty easy. So the standard deviation would be 0.52 times 1 minus 0.52. Oh, the square root of 0.52. 0.52.
Okay, so I put an equation square root of 0.52 times 1 minus 0.52 over 2,000. And I'm going to put that into Excel in just a second.
So I just put it into Excel.
Oh, nice.
So I got 0.011 if we're rounding to 3 decimals.
Where are the egg
Rounding to 3 decimal places, right?
Uh-huh. So 0.011.
Okay.
Is that what you got?
Yep. Yep. Good. Nice.
Okay, 2 more. Okay. So the z-score then. So the value minus the mean.
Yeah, value minus mean over standard deviation.
Okay, so the value we want to know.
Is 0.52, and the mean, I guess, is the 0.5.
The mean is 0.52.
Oh, it is?
Yeah. Because we want.
Oh, okay, yeah.
Yeah, the value is what we are usually trying to just to determine if it's. Whether the survey will suggest the candidate is
So I guess the value then is
0.5.
Or sorry. Yeah, 0.5.
Wait, so it's gonna be negative. Okay, over
So it's
standard deviation.
So it'd be negative 0.02 divided by 2,000.
Hold on.
That's gonna be a crazy number.
No, you divide it by the standard deviation.
Oh, okay, yeah, right,
So,
right, that's right. So 0, let's see. I guess negative 0.02 divided by standard deviation. What, round to 3 decimal places?
yeah, so I got negative 1.790.
Yep, me too. We're moving this. It feels good. At least if we get all right. Sure. 16. What is the probability the survey results will show the candidate is losing even though the true P equals 0.52? Okay, so probability. So we need to go to normal probability. I put right? And then put in negative 1.79 as our z-score.
Yeah, but where do we highlight this?
So we're trying to find out the probability of is losing. So I guess, let's see. So losing means getting less than 0.5. And that z-score relates to...
okay, so negative... 1.7. So we just highlight the left side?
Yeah, I'm not sure. I'm trying to figure this out here. And see it. I guess it has to be either just that left side or the middle and right side. You know, but yeah, he talks about losing, but the probability of losing being left side, that's only 3.67%. Like, I guess then all the right side is such a high percentage too.
Yeah, but if the what is this example again? So if the survey results are that like are showing that he's winning, then the probability is probably low, like that he could.
Yeah, that's true. I guess that makes sense.
You want to try it?
Yeah, I would try with the higher then. So then 0.963. Or no. I mean, sorry. Yeah, no, sorry.
7.
Yeah.
Okay. Okay.
0.036.
Oh wait, if you round up, right? So 0.037.
Oh, right. Yeah. And then the moment of truth.
Ah.
Oh, nice. 18 out of 18. Yeah.
Oh, phew.
We got them all right.
Awesome. Yay. Thanks, Dylan.
Yeah, thank you. You helped me understand a lot of that. Worked out.
You helped me totally understand what that half triangle or that population parameter is.
Population parameter, yeah, it's weird.
Okay, cool.
Okay. I'm gonna post the group collaboration, but as far as Wednesday, what was that? Do you have a question?
We're supposed to also do something to start our project, but
yeah,
I don't know if
let's see.
We can wait until Wednesday.
Yeah,
open the link.
True.
Let's just take a look. Do we want to check with him and make sure it's okay that our group is only 2 people still?
Yeah, we probably should email him before maybe he might want to combine us with people, because if this is like a lot of work for 2 people, then that would be pretty frustrating.
Right. Yeah.
So
let's start with that. And then Wednesday, let me make sure nothing's due for this, like right now.
I don't think it's due until like March something.
And there's a timeline to get started right now. Like, there's nothing that we have to like turn in.
Yeah, I don't think it's due until the end of the semester, but I may be wrong. Well, I guess the end of the semester is in April, so, and then March is the end of this week. So, but I guess if you email him about
I'll
that.
send him an email.
Yeah, I'll take care of the group collaboration thing, and then just let me know. But yeah, as far as Wednesday goes, what's the earliest you can do if you have like time to prepare beforehand?
I can do 9. So I'll just make sure I get the preparation done tomorrow, and then yeah, I can as early as 9 because
9 Mountain Time.
Mountain Time. So what is that for you? Is that 10?
Eastern. So if
You're
it's not,
Eastern now, 11.
yeah, so it'll be okay. I just need to
Yeah,
make a
because
note.
we are up around 8, and so that'll give me time to like wake up my brain and everything by 9.
Right, and if you need to do it later, it's no problem at all. Like for me,
No, that's fine.
because I have a super flexible schedule now, because I like most of the time I'm just doing Uber and other
Okay.
like house sitting and stuff, so it's pretty flexible.
Okay, yeah, let's plan on 9 o'clock on Wednesday, and then I mean both of my kids will be here, but hopefully like I mean I still like I figure it's no different right now since my daughter's not napping anymore really like